Using the same basic structure that we used to create this @bash cipher, we can also create a mirror writing cipher. Now, mirror writing is not very impressive, really. It's essentially just writing things backwards, right? So, like, hello, or ole, and world would be that? Yeah, that would be world. Draw, something like that, right? So that's mirror writing, and it's obvious what it is, right? It's not a great cipher. However, this is the first cipher that we're talking about that is transpositional. So transpositional means that the message is encrypted by changing the order or the arrangement of the message or of the letters in the message, not actually substituting them like in the previous ones we've looked at. So this also changes it a little bit in the way that you program it, because you can't just substitute one thing for another. You actually have to move stuff around. Now this one's pretty easy to do, and there's a couple ways to do it that I think are sort of neat. The easiest one, based on what we have already done, is to use a loop and basically to slowly add sort of one character at a time. So like, sort of like right to left. So like H, and then an E, then L, L, O, space, W, O, R, L, D. So we're essentially going to make the program do that. We're going to have the program write it backwards. So we're going to use this same basic design here. We're going to have some clear text, blank string to start with, a for loop that is basically the same thing, for C in clear text, and then it's going to print it. We don't need this though. We're going to do something a little different in there. So let's open a new text document file, and we'll start with the clear text. So clear underscore text is going to equal input, and the prompt is going to be, what is your message, or something like that. The cipher text, which is the encrypted message, for right now is going to equal an empty string. We're going to slowly build this. Well, it'll build it quickly, but we're going to build this letter by letter from here. So it's going to start empty. Now we're going to say for C in clear text. So C is basically character, right? So for each character in the message that they provide, we're going to do something. All right, so what we want to do here is we want to slowly add character by character into here, right? So if they type hello world, it gets that first H and it's going to go there. Then it goes to the E, right? So we want the E to go on the left of it because it's writing it backwards, right? So how do we do that? Essentially, we're saying that ciphertext is going to replace itself for each letter, and we're going to add the new letter in front. So it becomes itself plus C, or rather, that would be backwards. That would be like this. It's actually going to become C plus itself. So down here, 1, 2, 3, 4, we'll say that cipher text equals C plus itself. And then we can tell it to print cipher underscore text. Now, if we want to make sure it's actually working the way that I'm expecting, or that hopefully we're expecting, we could tell it to print the cipher text in here as well, so that way it does it for each step, each letter in that message. So let's go ahead and give it a shot. Hopefully I didn't make any mistakes. Mirror writing.py. Alright, so I'm going to launch the terminal. So cd desktop, Python 3, mirror writing.py. What is your message? My message is hello world. And there we go. So, although there's a problem. Why did it do 2 H's? I left that H in there from when I was doing the example. So ignore that H. But for the most part, it works, right? So H, H-E, H-E-L, and you can see just all the way down that it worked. So if I delete that, and we try it again, There we go. And we can see once again it go all the way across. Now it's printing this last line twice, and you might say, well, why is it doing that? And the reason it's printing the last line twice is because, well, it does it once here for when it actually hits that question mark, right? But then it does it again once it exits the loop as well. So that's why we see that last step in there twice. If I delete this and we run it one more time, now it will just spit out the results. Just the result. There you go. Now this is, like I said, a terrible cipher. It's super easy to crack. You can tell what it is pretty much just by looking at it. However, if you combine this with one of the other ones, so like Caesar cipher is also terrible, but if you combine them together, that's a little less terrible, right? Because you're rearranging the message and you're substituting the letters. Thinking about how you would stack them together can help you sort of rethink how you might design your own, as well as think about what methods might be better in securing information. Now, just like always, this isn't the only method to do this. There is actually a more efficient way to do this, but this is an obvious connection from the previous one that we wrote. So we'll talk about a different way to do this soon.